Have you ever looked at a picture of a dinosaur and just thought, how? How did they get so incredibly massive? I mean, we're talking about animals the size of buildings, walking around like it's no big deal. Well, you're not alone. It's one of the biggest questions in paleontology. Today, we're going to dive deep into the world of giants and uncover the secrets behind their colossal size. It's a story of lucky breaks, weird anatomy, and a world completely different from our own. So, grab your explorer's hat, because we're going back in time. First off, let's set the scene. The age of dinosaurs, the Mesozoic era, was a very different world. The climate was much warmer and more stable than today. There were no polar ice caps, and lush forests stretched across much of the globe. Most importantly, the air had way more oxygen and carbon dioxide. Think of it as a planetary-scale greenhouse. This high concentration of CO2 was like a super fertilizer for plants. Ferns, cycads and conifers grew bigger, faster, and more abundantly than anything we have today. So, you've got this Olecani buffet of plants stretching as far as the eye can see. What does that lead to? Giant herbivores. This is the first key piece of the puzzle. For plant eaters like the sauropods, think Brachiosaurus and Argentinosaurus. Their massive size was a direct response to this abundance of food. Being big meant you could have a gigantic gut, a huge fermentation tank, to digest all that tough plant material. They didn't really chew their food like we do. Instead, they'd strip branches bare and swallow everything whole, letting their massive digestive systems do all the hard work. Their long necks were also a brilliant adaptation. They could stand in one spot and graze on a huge area of vegetation, from low-lying ferns to the tops of tall trees, without wasting energy moving their enormous bodies around. It was like having a built-in cherry picker. So, step 1, a world full of supersized plants created the perfect conditions for supersized plant eaters. But wait, it's not just about the food. The dinosaurs' bodies were built for bigness in ways that mammals just aren't. Let's talk about their bones. If you look at a mammal bone, it's usually solid and dense. Heavy dinosaur bones, especially in the larger species, were often hollow, a bit like a bird's bones. They were filled with air sacs connected to their respiratory system. This is a game changer. It made their skeletons incredibly strong, but also surprisingly lightweight for their size. Imagine trying to build a skyscraper with solid concrete blocks versus using reinforced steel beams. The dinosaurs chose the steel beam approach. This allowed them to reach enormous sizes without their own skeletons crushing them under their own weight. This incredible system of air sacs also extended throughout their bodies, helping them to cool down. When you're the size of a bus and living in a warm climate, overheating is a serious risk. These internal air sacs acted like a built-in air conditioning system, helping to regulate their body temperature. Now, let's think about how they grew. Unlike mammals, which have a set growth period and then stop, many paleontologists believe dinosaurs had what's called indeterminate growth. This means they just kept growing throughout their lives, although their growth rate would slow down as they got older. They also grew incredibly fast when they were young. A baby sauropod might hatch from an egg no bigger than a football, but could reach a weight of several tons within just a few years. This rapid growth spurt was a great survival strategy. The quicker you get big, the fewer predators can mess with you. And what about reproduction? Dinosaurs laid eggs. This is a huge advantage over mammals who have to carry their young inside them. A massive mother dinosaur didn't have to carry a massive baby. She could lay multiple eggs and invest her energy into finding more food for herself to keep growing, rather than a long and draining pregnancy. This egg-laying strategy uncoupled reproduction from body size, allowing females to get just as gigantic as the males. So, we have a plant-filled world, lightweight skeletons, and a super efficient way of growing and reproducing. That explains the giant herbivores. But what about the carnivores? Where do giants like Tyrannosaurus rex fit in? Well, nature loves a good arms race. If your prey is getting bigger and bigger, you have to get bigger too if you want to eat them. T-Rex wasn't just big for the sake of being big. It was big because its dinner was huge. A fully grown Triceratops or Edmontosaurus was a formidable opponent. To take down prey like that, you needed immense size, powerful jaws, and a body built for battle. The evolution of giant predators was a direct response to the evolution of giant herbivores. It was a constant back and forth, pushing both sides to become ever more massive over millions of years. Each side drove the other to new evolutionary extremes. There's another factor we can't ignore: time. The dinosaurs were around for a ridiculously long time. The Mesozoic era lasted for over 180 million years. That's an almost incomprehensible span of time for evolution to work its magic. To put it in perspective, our own species, Homo sapiens, has been around for maybe 300,000 years. Dinosaurs had hundreds of millions of years to experiment with different body plans and push the limits of what was biologically possible. They had the time to perfect the art of being enormous. Different lineages of dinosaurs independently evolved giant sizes at different points in their history. It wasn't just a one-time fluke. It was a successful strategy that evolution returned to again and again. So, to recap the secret sauce for dinosaur gigantism, first, you start with a warm CO2-rich planet that's basically a giant salad bar. This allows herbivores to evolve massive bodies to process all that food. Second, you equip these animals with a unique anatomy, hollow, air-filled bones that make them strong but light, and a super-efficient respiratory system that doubles as air conditioning. Third, you give them a growth strategy of laying eggs and growing incredibly fast, allowing them to reach huge sizes quickly without the burden of pregnancy. And finally, you throw in a predator-prey arms race and give them 180 million years to let it all play out. It wasn't just one thing that made dinosaurs so huge. It was a perfect storm of environmental, anatomical, and evolutionary factors all coming together. They were the right animals, in the right place, at the right time. Holiday. Looking at the world today, it's clear why we don't have land animals of that scale anymore. Our atmosphere is different, our plant life is different, and mammals, with our solid bones, live births. And warm-blooded metabolism have a different set of biological rules. The biggest land animal today, the African elephant, is a giant in its own right. But it's a lightweight compared to the average sauropod. The age of land giants is over, but we can still look back in awe at the incredible creatures that once ruled our planet. They show us just how incredible and diverse life on Earth can be. Thanks for joining me on this journey back to the land of the giants. It's amazing to think about what it must have been like to see these incredible animals in person. If you enjoyed this video and learned something new, don't forget to hit that like button and subscribe for more deep dives into the mysteries of the ancient world. Let me know in the comments which giant dinosaur is your favorite. See you next time.